Hello, good morning, good afternoon, or good evening, whatever time zone you're joining us from. This is Jim McKeeth, and welcome to my session. Let me share my screen. This was going to be live, or going to be pre-recorded, and I had all these great things. I was trying to really bring it up a notch and add video effects and stuff, and it didn't go well. And we're doing it live, and hopefully everything comes across. If not, I apologize. You should still get the content. It just may not be have the production quality and engagement function. Again, things I wanted to add to it may not be as polished, but it will still be awesome. I am very excited about this session. I'm doing it. Stefan van As has created this fantastic library and worked with me quite a bit on the content here. So with that, let's go ahead and get started. Again, my name is Jim McKeeth. I'm Embarcadero Chief Developer, Advocate, and Engineer. Most likely you know who I am at this point, but my claim to fame is the patent and invention and patent of swiped unlock and pattern unlock that's common on smartphones, although I guess now they're gone to biometrics. But anyway, that's cool. I don't get any money from that, but I get to put it on my slides, so of course I'm going to do that. And joining me is Stefan van As. He's from the Netherlands. He created the Delphirium library as well as the 1Password for Windows and a number of other cryptography things, work for Macromedia, etc. You can find his contact information and such there as well. So it looks like the video effect is not coming through as well as I expected it to. Unfortunately, my apologies. Hopefully it doesn't make it unreadable. But for the agenda, we're going to do cryptography basics. And this is mostly because I'm a cryptography nerd and I love any chance I get to talk about cryptography, but I'm going to keep it simple. Honestly, most of this is going to be fairly high level. But my goal is to give you enough information and enough pieces that you can put this together and go out and explore this and discover and take advantage of some of the stuff that's out there. Yeah, so that's the agenda. I do have some definitions here for you, though. These are, I'm not going to read through all these now. I will have the slides available. Unfortunately, I discovered that trying to make the PDF of these slides did not go well because they got too big and I could not upload them, so I'll have to remove all the graphics and such to make them smaller. But these are some of the terms that you will see covered in the in here to one degree or another. Most of them I'll explain them as I go along, but know that you can go out and grab the slides, or honestly, if you just use your favorite search engine, whether it be Startpage or DuckDuckGo, you will find the answers to what these terms mean. Basics of cryptography. So when we're dealing with cryptography here, we'll be dealing with public key cryptography. And it's not that we're encrypting to hide things, but we're using it for a key signing point of view. The reality is that your wallet is a key public-private key pair. It's an asymmetrical key pair in that you have a public key and a private key. Your public key is available to everybody. That's your wallet address. Your private key is what you use to sign your transactions. So when you sign a transaction, the way that works is you create a cryptographic hash of something. And cryptographic hashes are used in the blockchain and all over the place. But so it's important to understand the basics of that. But a cryptographic hash is where you take some arbitrary amount of data and you create a thumbprint of that. And that thumbprint is always a fixed length, usually like SHA-256, it's 256 bits long. Now, a 256-bit number is astronomically huge. It's bigger than our brains can comprehend. It's a 1 followed by 77 zeros, or halfway between the number of atoms in the Earth and the number of years until the heat death of the universe, which is a long time away. So huge number. The odds of a collision is very, very slim. For all intents and purposes, it's not going to happen. So digital signatures are generated with the private key and validated with the public key. There's a library there for SHA-256 built into Delphi. but I'll also point you to some third-party ones that are used by Delphirium. Now we're going to talk about money, and so I wanted to kind of break down what different types of money are. And I found this taxonomy of money, which I thought was pretty awesome. And the basic thing I wanted to point out is specifically cash versus cryptocurrency. Cash is universally accessible. Anybody can use it. It is peer-to-peer in that I can just hand you some cash in person and you can accept that cash. We don't need a third party to validate that that cash is that I have the money in my account. But it's issued by a central bank. In the US, that's the Federal Reserve, and that central bank does things to control the value of that, to adjust inflation and such. So that's cash. That's what we're most familiar with. Cryptocurrency, you'll notice, is still peer-to-peer in that we can make a transaction with cryptocurrency without going through a central authority. It is electronic where cash is not, so we can do it virtually without being in person, and it's universally accessible. The difference being that it's not central bank issued. So this distributed independent nature of cryptocurrency is a very important factor in that it's not controlled or regulated by a third party. In that, just like if I hand you a stack of money, I cannot legally take that away from you, right? Cryptocurrency is the same way. If I give you, if there's a transactions completed via cryptocurrency, that is now yours. I cannot stop payment on my check. I cannot challenge the charges on my credit card. So that's kind of the important distinction there. This also lists bank deposits there in the upper left-hand corner, saying it's universally accessible. I disagree with that because there are a lot of people that don't have access to banks, and that's one thing about cryptocurrency is technically anybody that has access to a computer or a smartphone can have access to cryptocurrency, even if they don't have access to a bank. So cryptocurrency is more accessible than banks, than other types of currency.
I want to have a practical.
Oh, so the video audio will come through this. Oops. Let me do this via, oh, that's not going to work. Shoot. Let me turn off my screen sharing and I'll show here on the screen on the webcam. So the webcam should be bigger now. So I have this here is a standard US nickel. Nothing special about this. It is issued by the Federal Reserve in the United States, which is the central bank. The value is fixed at 5 cents, right? This is fiat money. It is issued by a bank. It is not based on a commodity, and it has the value is defined by law, if you will, and it's fungible in that I can take this nickel is completely interchangeable with any other nickel. There's nothing special about this nickel, and this showing up as a line in a ledger at the bank saying I have an additional 5 cents in my account is indistinguishable from actually possessing this nickel. The nickel does have some material it's made out of, but that's not what defines its value. The material itself is not what defines its value. This is, I just got this. I inherited this from my grandfather. My dad has had it and he decided to pass it on to me. Hopefully you can see that. This is a $5 gold coin from 1915 in the United States. This is made of gold. So this was issued by the government at the time. It was backed up by gold though, because it was made of gold. So therefore it is based on, its value was based on its material. Today, I could melt this down and it would be worth an amount of money based on its weight of gold. So the now it is worth more. No video. You should have. Hopefully, you should be able to see the webcam. If not, I'll turn the screen share back on in a minute. Sorry, I wanted to share the show this here. So hopefully, so it's worth more than the material it's made out of, though. It's worth because it's got sentimental value. Like I said, it was left to me by my grandfather. It was left to my dad, and my dad gave it to me. So it's got sentimental value to me. If you are a collector, you might have multiples of this coin from the same year, and then each coin could have a different value, for example, right? So based on its quality, its and what kind of conditions it's in and such. So it is non-fungible in that this coin is not interchangeable with another coin, similar coin. So that's an important distinction. This is based on a commodity. This is not. This is fungible in that it's exchangeable for, it's indistinguishable from its value of 5 cents. This is non-fungible. So mostly I wanted to show this off because I'm pretty excited about this. I think it's so cool. I've always been a bit of a coin collector, but then just receiving this I thought was pretty cool. And so I wanted to show that off. And I think it's a great way to help distinguish the different things when you talk about fungible versus non-fungible, commodity, fiat, etc. Isn't U.S. money an IOU from the Federal Reserve? So that's in the U.S. the currency used to be based on the gold standard, but then it was the 1930s, I believe, it was taken off of the gold standard. So it's not technically an IOU anymore. You cannot. It used to be that you could take, and I have a silver certificate someplace that was a $1 bill that was backed up by $1 worth of silver, and that I could take that $1 bill to the Federal Reserve and they would give me $1 worth of silver. That is not the case anymore. Once they went off the gold standard in the 1930s, which incidentally, so this is a 1915 coin. In 1930, they said all these are recalled. And so this was actually technically should have been returned to the Federal Reserve so they could melt it down. I'm glad it wasn't. I think it was the 1960s when they no longer were demanding these to be returned. But yeah, they're no longer IOUs. Let's see, Renee's saying, I'm sure your $5 gold $5 are exchangeable against five green $1 paper bills. Yeah, most people would give me $5 for that. It's definitely worth way more than $5. I would not part with it for $5 because, like I said, it has sentimental value as well as the.
One of the practical examples.
So let me share my screen again. So what is Bitcoin? Bitcoin, so if you haven't looked at the story of Bitcoin, it seriously, if it was a movie, you would say this is too far-fetched. Satoshi Nakamoto wrote this Bitcoin paper, and it was revolutionary. It brought together some things that were existing, but then also solved some problems that had previously been considered insolvable. He established Bitcoin, established blockchain, and but then it was discovered he wasn't a real person. He didn't exist. So pretty crazy. There's been lots of theories about who he was, if he was a group of people or whatnot. People have claimed to have been him, but then turned out not to be. You can actually still read his original paper. It's not that long. It's about 8 pages, very accessible, highly recommended. I actually thought about doing a deep dive and just going through the paper, but I don't have time for that. I'm probably going to run over it as it is. But the idea with Bitcoin is that there would be distributed miners that would maintain a blockchain. And the blockchain was the transaction ledger that used proof of work timestamps to prove that consensus. So consensus was the big thing. It was how you prevented the double spending issue, which is what was the previous problem they had with decentralized currencies. Interestingly, all transactions are in Satoshis, which is named after Satoshi Nakamoto, which is the smallest unit of a Bitcoin, which you can see there. And I looked it up. 16 Satoshis is roughly 1 US cent as of right now, although prices fluctuate quite a bit. A block on the Bitcoin is completed every 10 minutes. So a transaction is not completed on the blockchain until that block is finished. So your transaction, when you make your transaction, it is going to be in the next block. So in 10 minutes, could be added. It may not, because the block may have as many transactions as it can have, and at some point later might be on there. But then every 10 minutes, though, a block is completed. And the miners, who are the people that validate that block, are paid 6.25 Bitcoin. That value decreases over time. The goal is that Bitcoin will eventually stop being mined, that mining will stop producing Bitcoin, so that Bitcoin has a finite amount, because the idea was to make it similar to gold and that was a finite resource. You use your wallet to access your Bitcoin. The digital credentials, like I said, are public-private key. Your private key is what you use to access your transactions. So I'm going to show you a library that does work with this for doing from Delphi to work with Ethereum that was developed by Stefan. So Ethereum, we don't hear much about Ethereum. It's the second biggest blockchain cryptocurrency out there. You hear about Dogecoin from time to time. Elon Musk is a big fan. I'm a big fan of Ethereum. Ethereum was kind of like, hey, what are these cool ideas that Bitcoin invented, and how can we evolve this? Ethereum is very much tries to build on the technology, tries to continuously improve it, whereas Bitcoin very much is like, hey, Bitcoin is a revolution. We're going to stay with the way it was written. There's very little change to the way Bitcoin works, whereas Ethereum's continually evolving and advancing. One of the big things, though, that Ethereum does is introduce what's called smart contracts, which I'll talk about more later. But a smart contract is a program that executes on the Ethereum virtual machine, which is a decentralized Turing-complete virtual machine on the blockchain. So a smart contract is essentially a program that does some sort of transaction based on various things that runs on the blockchain. Most smart contracts are written in Solidity, which is an object-oriented programming language. I believe it's based on JavaScript, but there's also Yule and Viper. Viper is based on Python, as well as other languages. Ether is the cryptocurrency on the Ethereum blockchain. You'll also hear discussion about gas, which is an internal transaction pricing mechanism for, it's used to mitigate spam and other things, but it's paid for in Ether for transactions on the Ethereum blockchain. I did want to also call out Pascal Coin. Pascal Coin is a cryptocurrency that is written in Free Pascal and Delphi. You can find out more about it on its website, it's right down there in the lower right-hand corner, pascalcoin.org, and it's available on GitHub. It tries to solve some different problems based on Bitcoin. It evolves from Bitcoin, if you will, but it's interesting in that it is you can take a look at it. It's pretty cool. Like I said, it's written in Pascal. I'm not going to go into too much detail on it. Yes, gas is used for transaction fee. Yes. Trying to keep an eye on the questions as well. Okay, so the gold standard was ended in 1933 by FDR. That's what I thought. Also wanted to point out EasyMiner. EasyMiner is another Delphi application that is used. It's a graphical front end for mining. So if you're like, hey, I wanted to get into mining of these coins, which we'll talk more about what that means later, then you can use EasyMiner for that. There's the links there. It's open source. Okay, so now let's talk about the blockchain. And I don't know that I have my demo ready to go for this, but the blockchain is really, really, really interesting. It's a combination of some existing technologies, but really came together in a way that was unique and revolutionary. And I think, and some other people say, it may be a bigger deal than Bitcoin because it has use cases beyond cryptocurrencies. But the idea is, if you have no central ledger, right? If you have no centralized authority that says this is true, this is the true case of transactions, like your bank, for example, if you're writing a check or using your debit card or check or credit card, how do you know which ledger is true? So that's called the problem of consensus. So the way blockchain solves consensus to prevent double spending, which is where you can, so I have the slides available. I can't type the links out as I go or I'll be forever. Most of them will be pretty short though. Okay, so double spending is be where I could spend money, give money to one person, and then give that same money to somebody else, and they could both look at the ledger and say, "Oh yes, Jim does have X dollars or X units of currency, so therefore he can pay me X units of currency." But you won't know that I already paid somebody else those units and actually have no currency left because I've already given it away. That's double spending. So the way that that's solved is through the blockchain. And so what that does is when a new block is added to the blockchain, when a new set of transactions take place, that single block of transactions includes the hash of the previous block. So you can think of it kind of like a linked list from computer science, except instead of an address, it is the hash of the previous block. And so if some of those previous transactions change, then this block will be invalid. Now, the interesting bit is the way that proof of work is done, which we'll talk about more in a second, to make it impractical for somebody else to regenerate a different block with a different set of transactions in it. So the consensus is based on the longest chain because there's a inherent difficulty in the way the blocks are generated. And I think, so I'll talk about that in mining. So the first block is called the Genesis block. It's what sets things up. And then after that, each additional block does hashes the previous block. So the security comes from the fact that if the majority of the nodes are not colluding, and then that they are not all trying to create the same false set of transactions, then the whole network is secure. So it requires that over half of the network be in on the same fraud for it to be secure. And so the idea is that it's more profitable for each of those nodes in the network, the members of the network, to do legitimate transactions, to do legitimate mining on the network, than it is for them to try and all collude in fraud. And it works. This has been successful. A lot of people were skeptical of Bitcoin, but it's still going. Ethereum's still going. These are still going. This is working. It is mathematically, when you look at the math, when you look at the computer science of it, it makes sense. You look at it in practice, it makes sense. So here's an example of a blockchain, and I'm not going to do the breakdown of it, but essentially is that you have some data, an ID, and a timestamp. The data would be your list of transactions, and then a hash. Now, the first one is the Genesis block, and then this hash includes the hash of the previous block in it, right? And so if you were to change this one, let's say if you change this block of data, then all of the hashes after it would change. Now, hashing by itself is fairly easy to do. It's fairly quick. But the creative thing is the way proof of work mining goes. So what is mining? It's called mining, and then it's kind of like mining for gold. You are mining for a resource, a commodity. You, as the miner, get this payment, but you also produce a value for the network. So the mining that's used right now on Bitcoin and Ethereum is called proof of work. So mining is the process of finding a nonce, which is a number used once, that generates a hash meeting current difficulty target. Now, the current difficulty target is the number of leading 0 bits that it must have. So that changes every 2,000 blocks, which is roughly 14 days, based on the current production power of the network. So as the network gets more power, as they get more computers mining, then the number of required zeros changes in order to try and maintain a target of a block completing every 10 minutes. Okay, so theoretically, it is possible that the first miner, first nonce, could produce the correct block, could meet the requirements. But on average, and we're talking about big numbers here, it is going to happen every 10 minutes. So some may be a little less than 10 minutes, some may be a little more than 10 minutes, but on average, it's 10 minutes, and it adjusts based on past performance to maintain that. So you have to hash it, you have to run the hash algorithm and then check those leading bits. And if those leading bits are not 0, then you have to run it again with a different nonce to try and get that. Now, as the miner, you include there's a transaction included in there that says you get the 6.25 Bitcoin for completing the transaction. You also get transaction fees, which is separate, but then once you produce it, you broadcast that out to the network and say, hey, everybody, there's a protocol involved in this where you broadcast this out to say, I've found the hash or found the nonce that produces the hash that meets the requirements. And everybody says, oh, yep, you did. And then you get the Bitcoin and the transactions, the mined Bitcoin and the transaction fees go to you. If you broadcast it out and everybody's like, no, this doesn't meet the requirements algorithmically, they can prove that it doesn't work, then nobody accepts that and your block doesn't propagate. In theory, you could have 2 different nonces that were generated at roughly the same time that both met the requirement, but the next one that happens, right? The next one that happens would be the one that would determine which was successful. So in case of a conflict, once the next transaction happens and that transaction is accepted by the majority of the network, then you have consensus and the longest chain wins. So there's other proofs out there, which we will talk about another one in a second here. But the big problem with proof of work is it uses a lot of power, a lot of electricity. What you get from mining is directly tied to, I mean, it's essentially, the trick is finding a way that the hardware and electricity invested isn't more than what you get from mining. The more people that mine, the more efficient things get, the harder it gets. It keeps balancing out. It's capitalism in effect. So, but it uses a lot of energy. So people criticize blockchain and Bitcoin because of that. It produces pollution. It uses a lot of energy. There's a lot of expense in running the network. Now, proponents of Bitcoin and other blockchains point out that the credit cards and banking also uses a lot of energy and pollution as well. But so, it's 6 of one, half dozen of the other. Although there is an alternative, and that alternative is called proof of stake. Now, Ethereum has announced they're going to proof of stake next year. This is a big deal because this solves the expense, the energy expense and the pollution produced by mining. And so the way proof of stake works, and it took me a while to wrap my head around this, is that everybody stakes 32 plus Ether coin, and then they validate transactions. And as long as everybody everybody that staked out their coins agrees in the transaction, then they all get a portion back, right? So they all earn a little bit of coin for staking some coin and then coming to consensus. Now, if somebody's like, well, I'm gonna make up my own transaction that gives me extra money, everybody's gonna say, I don't want to do this because I get nothing out of it. You're the only one that gets something out of it. So therefore, there's no reason for me to go buy into your lie, and they will not agree with them. And since they do not agree with them, the person that has created the false transactions will lose their stake. So that's why it's called stake, is you're putting that up in order to participate. Now, so this is the same thing. As long as the majority, over 50%, are not colluding, then the network is secure. The thing that's interesting is that proof of work is used to establish a blockchain, establish a cryptocurrency, get it rolling. But then when you switch, then you can switch to proof of stake. Proof of stake only works on a existing established network, but it doesn't have the energy it cost. There's a little bit of energy cost, but it's much, much less. And it does not, it still keeps it decentralized, today it's actually really hard for somebody to get involved in blockchain mining because of the cost in getting in. It requires a lot of hardware, and you're most likely not going to be the one that gets it because there's so many people mining. Whereas this, anybody that owns any Ethereum at all, or 32th Ether, can be involved in this. They can stake those Ether, and they can earn Ether. They can be a miner. So proof of stake, very exciting, and it is going to make nature happy. It's going to bring balance to the forest, if you will, and make it sustainable again. This is going to make a big deal in making mining much more sustainable. So let's talk about smart contracts now. You probably all signed a contract. If nothing else, you've clicked through a license agreement and not read it. But smart contracts are really, really interesting. Basically, the idea is, like I said, a smart contract is a program that runs on the blockchain. It's a microservice that runs trustless, which means you don't have to trust it. It just does what it says it's going to do, right? So there's no, hoping that they're not lying to you or anything like that. You can read it, you can see it, you can tell what it's going to do. It's more concise than a traditional contract, and it runs on the blockchain. It's immutable. It can't be modified once it's created. So smart contracts is something that I'm not sure if Ethereum invented it, but Ethereum's really perfected it or popularized it. And it is what's the basis, the foundation of NFTs. Once a smart contract's added to the blockchain, it can't be modified. It's public. And this assures your users that the rules are transparent and will never change. So what does that mean? How does this make it cool? So a lot of contracts will say subject to change, or this contract is governed by the laws of such and such jurisdiction, and you agree. If you don't agree with, if at some point you want to argue with us, that you'll go to moderation of the moderation company we've picked and done it. And it's one of those things. It's like you need to get a lawyer and say, I don't understand what this is trying to say. I feel like it's going to take my firstborn child, but I don't know what to do. And it's complicated. It's hard. So smart contracts avoid all of that, especially for you as a programmer, in that it's written in programming language. It's mathematically provable. It is it's easier to understand because of that. So especially you as a programmer, you don't need a lawyer to understand or translate the contract. So let's take a look at a Solidity smart contract example. This is a simple smart contract in Solidity. It has comments here, but you can see that it is fairly understandable in that you have a public address, that the minter of the contract, that has events, allow clients to react to declared contract changes, constructors, here right here we see balances, adding amount, or removing amounts, adding amounts, basically straightforward. So you can read this, you can see what's happening, and it can't change. Well, if it does change, the contract can include provisions that give you the ability to accept or reject the change. So that leads to NFTs. You hear a lot about NFTs, but it's hard to get past the news headline about some JPEG that sold at auction for a huge amount of money and understand technically what's going on with NFTs. So NFT is a unique, right? It's immutable, non-fungible. So like this coin, non-fungible token. It's unique asset that's owned on the blockchain. Basically what that is, it's a link to a digital asset or something that defines a real world asset, that then the ownership, the transaction of that is defined on the blockchain. So sometimes the ownership does not, or the ownership of the NFT does not translate to, or translates to certain rights. It's not all rights. So an example I was thinking about is there's these services that will sell you a star, where you can buy a star and they'll send you a little thing that says, oh, you bought this star at this address and here's the details about the star, and it now has your name on it. the company that's selling you that star doesn't own the star. They don't have the rights to give you that star. But what they've given you is they have a list, a database of stars that they've now put your name next to it, right? So if at some point in the future we build a rocket ship and someone flies to that star, you can't show up and say, hey, I own this star, you can't take it. That's not what you got. Instead, you got a listing in their database that says you own that star. Now, that's not exactly the same thing, but essentially is that you've got your name next to this asset on the blockchain that says you own it. Now, a lot of people are like, oh, it's just putting your name in a closet someplace. There are other blockchains besides Ethereum that people are using for NFTs. So that's a big deal, right? If it's Bill and Ted's excellent blockchain that you own your NFT on, then yeah, that could disappear tomorrow. There may not be enough people involved to have consensus. There's a number of issues. Also, the thing with NFTs, right, is that maybe the person you bought the NFT from didn't have the rights to give you that whatever it was you had. So you need to do the due diligence a little bit, and all that stuff is supported through blockchain and digital security and things like that. That's something we can do, but right now people are going crazy for NFTs and they're not doing the due diligence. They're just going after them. Usually, like I said, they're usually on Ethereum. They don't have to be on Ethereum, but Ethereum defined it in the ERC, Ethereum Request for Comments 721. So you can go out and read Ethereum 721 that defines how a NFT works, smart contract for NFT works. This is something else that's pretty cool. It's the InterPlanetary File System. This is usually used for NFTs. It's a distributed file system. If you're familiar with BitTorrent, it's kind of an evolution of or inspired by BitTorrent, but it's a separate thing. The idea is that anybody can publish something to the InterPlanetary File System. And in publishing it to the file system, you get a hash, and it's added to a distributed hash table. So anybody can connect to a peer, and they will then be able to access that hash table. And they say, hey, I have this hash. Someone give it to me, and they can send that to the hash table, and then they'll point them, and then they'll copy that, and then you'll get a copy of it, and it will exist, and you'll have a copy of that. So your file name is the hash of the contents. Filecoin is a reward mechanism that was set up for people to store files on the IPF. There's also pinning services you can use where you can pay money for somebody to pin a file for you so that it continues to exist. It's supported by Cloudflare, Brave Browser, and actually a number of other services that do support it. There's a few comments here. If you're interested in writing your own native blockchain and read this tutorial, interesting. Yep, there's a lot of examples out there. Holochain protocol doesn't need mining. Interesting. Where's Delphi in this? We're getting to it. I told you at the beginning, if you weren't paying attention, we're going to get to the Delphi part. It's the Delphirium library. More discussion about the gold standard. What would happen to the world economy if there was a huge flare explosion, which I don't know. What would happen? It would be astronomical if it didn't kill everybody. Yeah. I mean, we have a lot of things electronically. Let's see. So InterPlanetary File System. Let me jump out here to this. I installed it. Where's it at? So I installed the desktop version of it, and it's not. Wait, there it is. Okay. It, for some reason, wasn't running. So you can connect to You can connect to somebody else's node endpoint, or you can set up your own, install it and run it yourself. I'm running it myself. And hopefully, if it didn't lose my files, I have some files published on here. You know what I should do? I should publish the slides to IPFS. I will do that. Come on, files. There we go. So I put the DelphiCon logo here in this, and so I can share out this address, this hash, and anybody can connect and grab this logo from the InterPlanetary File System. Now, it's called InterPlanetary File System because of the replication, way the replication works. For example, if somebody was on Mars and they wanted to request something that was on Earth, it would have to travel to Earth to get it. But then once it came to Mars, it would be replicated on Mars, and you wouldn't have to go back to Earth again. It's really cool. There's a lot you can find out about it. I suggest you do some more research. And like I said, I will publish the slides on here because they were too big to publish the other way I was going to do it. All right, so let's go back to my slides. Unfortunately, I am running slow on time. So Delphirium, for the people that were impatient and didn't catch the part at the beginning when I said I was talking about Delphirium once I established some of the basics of this, is a library developed by Stefan that gives you the ability to interact with Ethereum blockchain. Actually, it supports any of the Ethereum virtual machine compatible networks to create distributed decentralized applications that run and interact with the blockchain. You can interact with smart contracts, you can interact with the interplanetary file system, you can do transactions via Ether, work with wallets, etc. It's open source, it's available there on GitHub. There's no runtime dependencies, it's lightweight, self-contained. It's based on Web3, which is essentially the standard web3.js. And yeah, so here is a short bit of code that does gets a balance of somebody's wallet. And I will show you this code in action, but I wanted to dissect it. Here's the uses clause over here. It uses Rudy's big numbers library, the integers from big numbers library, which is a fantastic library, also open source. And then here's the other units it uses in this example. So the first thing we do here is we create a client connection to the desired blockchain endpoint. So you have to have an endpoint for the blockchain. This can either be where you're running Ethereum yourself and have your own node, or you can be pointing to somebody else's. So you get an API key that gives you access to somebody else's instance. Once you have that, the client connection, then you need an address of a public wallet. Provide the address to the public wallet, and it then makes a call here. We're using anonymous methods to do this asynchronously. And first thing we'll do is check to see if you got an error. If you did get an error, in this case, we're raising an exception. If you didn't, then the value that came back, the quantity that came back is in WEI, W-E-I. So in Bitcoin, Satoshi is the smallest unit of measure of the transaction. In Ethereum, the smallest unit of measure is a WEI, W-E-I. And so we're converting from a WEI to Ether in this case, and then we have the value of the wallet. And so what we're doing now is we're just putting in the list box, we're displaying the address that we pulled it from and the balance. So now let me show you this in action here. I'll run this example. This is, I'll show you the code. Oops, scrolled too much. Oh wait, this is the wrong one. Man, I'm not having a hard time scrolling for some reason. So there's the code I just showed you there on the click event, and we'll run this. Now, right now I'm connected to Ganesh. I can't remember how to pronounce this. This is a trial one that you can run, that if you just want to have a test instance to connect to, you can do that. And I hit get balance, and that is this one right here, this address, and it says, yep, there's 100 there. All right, not very interesting, but we can go here. Oh, so here's the link. I'll put the link in the chat since this is your brain hurts. Sorry, yes, I will try and have the slides. This has been a huge roller coaster ride for me as well, just trying to wrap my head around all this and then make it accessible. Hopefully, I haven't made it more complicated by trying to explain it. So this is Ethereum. Here is the big numbers library. These are linked down below. This is a bases library, base 1632, etc. Here's a hash library, and here is a crypto library that is all used by that. If you install all of those things, then you can then build these examples. There is a number of tutorials that are available here as well. There they are. Follow those tutorials so you can figure most of this out. I'll send my code over so they can be added as well. So this is Etherscan, and you can come here and you can get a address of a wallet. So this wallet has, actually refresh it, it might have more than that now. Yep, it does. 8,319, no, 8 million. Oh, that's a lot of Ether. So I'm gonna get this address here, and I'm going to switch over to this. So this is Alchemy. I have an API from Alchemy, and I will then put that address here and hit get balance. And so it's going to go out and hit Alchemy's API and provide that address I just put in here, and we see 83190. Yep, that's it. So we've just queried somebody else's public wallet to find out how much Bitcoin they have, or not Bitcoin, how much Ether they have. It's really that simple. It's a very simple to use once you get your brain wrapped around. That's why I spend a lot of time explaining it. It's hopefully to help this all make sense for you. So that's the get balance example, which I just showed you the code for. So now let's look at some NFTs. NFTs, so that I have another example that Stefan made for me that lets you view NFTs that are defined by the ERC 721 spec. There are NFTs that aren't on Ethereum or any Ethereum compatible blockchain. Anybody could say, hey, yeah, I have some NFTs. It's a spreadsheet right here that I put your name next to. I just write it down, you know. So not all NFTs are created equal. This is a collection that Stefan sent over. It's a collection of classic computer collectible cards. I suspect that the person that made this didn't actually have the rights to these images, these cards that they're doing, but they're doing them as NFTs anyway, and they're kind of interesting. So let me come over here. This is the page for OpenSea's and Explorer site where you can explore NFTs. So I actually, if you look at the images here, there is a down here it says 8-bit kick. I went and looked. 8-bit kick was a Kickstarter for these 8-bit collectible cards. It's Creative Commons by share alike. So I mean, technically, whoever this BBE7FB is, they could have. I mean, they're using it under Creative Commons license, so technically they could be doing this, but they did not. Probably not the person that created these cards. Anyway, but you could investigate these via Delphirium. So the way you do that is if I click on one of these here, which I just did, and then I went back, we see right here that they have this address for the collection, and this is card number 11 in the collection. If I go to a different one, we'll see the address stays the same, but the card number, the NFT number in the collection changes. So we need this collection address. And then we come over here, close the other example down. And in here, there's that address right there. I can go back and look if you want to double check and see, yep, that's it. See, you memorized that big number that quick, didn't you? Because you're smart and I haven't worn your brain out yet. So let's run this. So this is going to go out to the Ethereum blockchain. It is going to find this collection via the address using NFC 721. It will then find out what's in the collection. It will then, oh no, let me fix that. I don't have the, give me 1 second here. I have to have the key API key in it, and I don't. All right, let me fix that real quick because I do have a copy of it. It's just here. Nope, it's not there. Where to go? Ethereum samples, endpoints. Apologies. I will run this again and put that in the right folder. Um, 1 second here. Sorry. I moved computers I was running this on because I thought this would work better. And I it's in here maybe. Yep. One more try. I, what did I do? I gotta find where the file's at. Home path should be. All right, here, let me just do this. Instead of pausing this, I will debug it and figure out why it's not working. Did it? Oh, there it is. All right. I gotta change my key anyway. Okay. There we go. Error. This worked. Oops. Well, you can see there. So there's the computer. Something I must have changed something. But anyway, there is the cards. It went out and grabbed this. So this, we see here's the text, and there's the image from the InterPlanetary File System. So this went. We can look at the code here. Live demos always. I've got 2 minutes. Oh, all right. I'll wrap it up. You can look at the code later. The code's up on GitHub. Okay. NFT Browser Example, I did that. Use cases, I will get this up there. But there's a lot you can do with this. This is a quickly emerging technology. There's some tutorials that are up there that you can check out as well. Oh, I didn't show Bankless. This is an app that was developed using Delphirium that lets you do investment management. Pretty cool. You basically, they're all based on smart contracts. You can transfer money out of your wallet into other wallets or other smart contracts that have a rate that they're paying you back based on a smart contract, and you can manage your investments this way. It's available on Windows and Apple. So here's the part where I'm going to spin the crystal ball and look into the future. We are going to run a little bit over. and that's okay. So this is coming in the future, is the shard chains in layer 2. This is going to really enhance. One of the problems right now is Ethereum is so popular with NFTs, is there's so many transactions on it, is that is making the price of gas, the transaction fee, too high. So you so the shards in layer 2, you can read more about it here, is going to improve this, make it faster, more transactions can happen, lower the price of gas, lower the price of transactions. I'm not going to have a chance to go through this. Gartner does this thing called the hype cycle, where they look at emerging technologies. They plot it on this graph here, showing innovation trigger, peak inflated expectations, trough of disillusionment. So this peak of, let me jump to 2021, non-fungible tokens, NFTs, are at the peak of inflated expectations. That means everybody is talking about them. You go and talk to your grandmother, and she's like, hey, dear, I picked up an NFT. Do you want to see it? And they show you a printout, and they don't know what they bought because everybody's hearing about it on the news. That's where NFTs are right now. They will then go into the trough of disillusionment, which is when you are, I don't know what this was. I was silly. This is, so right now it's exciting, but we really don't know what it's going to look like when it finishes. Then it goes through trough of disillusionment and then enters the slope of enlightenment, which is when we figure out, oh, this is what it's really for, and finally reading the plateau of productivity. So Gartner said, based on their expectations, were that they would reach plateau of productivity for these, come on. There we go. The blockchain was expected to reach plateau in 2020 to 2023, so we're right there now. NFT to reach it in 2023 to 2026, and DAOs, which is Decentralized Autonomous Organizations, to 2024 to 2029, which Ethereum runs on a DAO. Decentralized finance, which Bankless lets you do today, they expect to reach it in 2026 to 2031, and yeah. This is just the tip of the iceberg for this technology. There's a lot coming, a lot of great stuff, and clearly I had more content than I could cover, and I encourage you to go take a look at the libraries and things so that you can discover more and learn more. Thanks to Stefan, he was online to help with questions, and unfortunately I just ran way over because I had too much stuff to cover, and I apologize. Nick Hodges' session is up next. His session is fairly short. I will launch his session here so that he can get started, but I will try and stick around and answer some questions here at the same time. So let me see if I can multitask for a second. Oh, come on, go to webinar. All right, go to webinar's not letting me launch it, so I have to close this one down. There's a lot, hopefully, my goal with this is to give you enough information that you can go do a little more research and discover more on your own. Go check out Delphirium. You can contact Stefan. He's incredibly knowledgeable, very excited about this stuff. And you can contact him as well. If you contact me, I'll just give you a copy of my slides again. But I will get those published on the site as well. All of the stuff will be published on the delphicon.embarcadero.com. You can find it there. And yeah. There will be recording and the slides and stuff available there, yes. All right, so I got to shut down and start up so Nick can join. Thank you, Stefan, for all your help in this, and apologies for not having this as polished as I wanted to, but I was ambitious and didn't get it all working. So let me switch over to Nick. See you all on the flip side.